All right, so in this question, we have a boat traveling in the water, and there's a number of directions given, compass directions. East is the direction of the boat's heading, and the river itself is going to the south. So let's kind of get ourselves some bearings here. Let's say this is our river, and it's going to the south here, and our boat is traveling to the east. So this is the east side, this is the west side. All right, so we've kind of got a sense of the directions here. So what we can say is that our boat is traveling this way, traveling at 40 meters per second. And what we're going to be doing here to find its overall resultant velocity is we're going to add to that velocity of the boat, we're going to add the velocity of the river, which is to the south. So from the head of this first arrow, we'll draw the tail of the second. And I've tried to make that a little smaller since 15 is less than 40. All right, and then our resultant that we're going to try to find is this right here. That's the actual direction the boat would go, and we're going to describe the angle. We could either describe the angle with respect to the shore or to the boat's original direction, and I guess that's what I'll do since that's the angle I've drawn. All right, so let's go ahead and make some calculations here. To find that black arrow's size, we would use the Pythagorean theorem, and that would give us a velocity, so I'm going to label it v. The square root of 40 meters per second squared plus 15 meters per second squared. Okay, and when we work through that, it comes out to be 42.72. I'll leave a few extra decimal places in case I need them later. And then I need to find that angle that I've got marked. So the opposite side of the triangle from that angle is 15, and the adjacent is 40. So we'll use the tangent. Tangent of theta is equal to opposite over adjacent. All right, so we would plug that in as 15 over 40, and then do the inverse tangent of that, and find that our angle is about 20.56. All right, so now we're ready to answer that first question here. What's the boat's velocity? So we'll round at this point and say it's 43 meters per second, and the angle is about 21 degrees. And the boat was originally traveling to the east, so that's my reference direction here, right here. And I'm below that or south of that by this 21 degrees, so south of east. All right, second part of the problem asks if it takes the boat 2.5 seconds to reach the opposite shore, what is the width of the river? Okay, so we're looking for this distance right here, directly across the shore. Now you notice I drew that on my picture. That helps me make sure I pick the correct velocity vector. If the question was asking me about a distance down shore or down the downriver, that would be pointing this way, and then I would pick the 15 meters per second. But because it's asking me for a distance across the shore, I'm going to choose the arrow that also points in that same direction, the 40 meters per second. Most people would think that I'm going to be using this 42.7 because that's what I just calculated, but that is not the case in this problem. All right, so we'll say that distance is velocity times time, and our velocity, again, that we're going to use here is the 40 meters per second, and we are traveling for 2.5 seconds. So that tells us that the distance across must be 100 meters. All right, part C of the question asks, in what direction should the boat head so that the boat lands in that point directly across, that 100 meters away? All right, well, let me redraw my sketch real quickly here. So the idea is we found earlier that if the boat goes this way, the river carries it down, and so it ends up going at this angle below. We want the boat, if it starts here, we want it to actually end up directly across. So in order to do that, the boat's going to have to not go directly across, but go a little bit against the river, so that when the river brings it back, it's actually going directly across. That's the triangle I'm working with. Now, that doesn't mean that my angle is the same, it's just flipped up. What it means is I need to do some recalculations. Let me get some things labeled here. So the boat, as you recall, actually I don't recall, hold on a second. Sorry, had to look back at my slide here. The boat was traveling at 40 meters per second, and the river was at 15. All right, so now what's different here is the boat, its boat's speed, as if it were in still water, that speed is actually the hypotenuse of our triangle. And so when we're trying to find, if we were trying to find this speed, we would use the Pythagorean theorem, but we would subtract 40 squared minus 15 squared. But that question isn't really what's being asked here. I just want to know what direction the boat should be heading. So really what I'm trying to do is I'm trying to figure out this angle right here. All right, so let's go ahead and do that. Let's notice that I know the opposite side is 15, and I know that the hypotenuse is 40. And so that tells me that the sine would be the best function here. So sine of theta is the opposite over the hypotenuse. All right, and so we would do the inverse sine of 15 divided by 40, and we end up with about 22 degrees. So our theta is 22 degrees. And again, remember, don't just stop there. That's not enough of an answer. That doesn't tell us in what direction that 22 degrees points. When we look back at our picture, the reference line here is the east direction, so that's going to be a part of my description, and I'm above that by this 22 degrees. So we would say 22 degrees north of east. That's the direction the boat should head, and then it would land across from where it started.